I'm with dashjoin.com. We do a open source low code development platform that was used to build the solution. And I'm joined here by my colleague. Over to you, Ege.
Hi, Andreas. Thanks. Yeah, so we have built this Web of Things manager, and to really explain what it is, we have to dig in a bit into, what is Web of Things in the first place. But before that, let's look at IoT. So I think we all heard of IoT in different ways, but nobody could, reject that it's a very big market with many, many devices connected to the internet. And actually, it is wonderful. We have many devices, but actually this brings a bit of fragmentation. We have different protocols, different ecosystems, and it's not exactly the case like the usual web that these devices are interoperable with each other. That's why we have thought to change these things a little bit. And that's where the Web of Things come into play. Web of Things is here to counter this fragmentation of IoT. It's a standardization activity by the W3C, so the World Wide Web Consortium, where all the web standards are happening. And it's actually just about providing device metadata. So if you are looking at all these protocols of different devices and different ecosystems, we can just apply the thing descriptions and counter this fragmentation. So here is what we call the narrow waist model, where we basically provide the thing descriptions of the devices, which can contain different protocols. And thanks to the properties, actions, and events paradigm, we are able to build applications on top of it, which is actually crucial for our application that we have built. So the thing description, here we see an example of a publicly available device provided by the Eclipse Foundation. And here we start with the top level. So here we are seeing some terms that you might be familiar with if you are working with JSON LD. And we start by giving some context, which allows us to enhance this device with other ontologies that are available. And here we are already starting to see some device metadata. So here we see the security context. So the security is basically inspired a lot by the Open API, but it actually can contain other security mechanisms from different protocols. And this can basically contain basic authentication, OpenID, and so on and so forth. Here, for this basic example, we are just showing the NoSec. We can go further and describe the properties and the other interactions of the device. So it's very important that all of these interactions and the data available of the device is done via JSON schema. This allows us to describe different payload formats that are usable by any JSON schema implementation, which is already very powerful. Actually, here we are seeing a property, so the resources of a coffee machine. And this is actually the first type of interaction that you can model with a thing description. With properties, you can describe device configuration or sensor values, but you can also go further with actions, and you can describe the operations you can call on the device, like brewing a coffee. Also with events, so we can go into the more asynchronous interaction patterns, and we can describe asynchronous device events. For example, when the coffee is finished, or if the device has no beans left, these can be basically observed by the different clients. And very importantly, with each thing description, it's not just description of any device, it's really concrete device endpoints. And that's exactly what's happening with the forms array that you're seeing on the screen. So with the forms, we are able to pinpoint exact device endpoints and resources, but also content types of this exact payload. And we can also go further to say that this is a post request, but it could be that in another device, it's a put request, and so on and so forth. So we are able to model devices with different protocols and behaviors. By taking the Web of Things, we have thought of building a generic application, which is called Bot Manager, based on the Dashjoin's platform. And we basically had a very simple design goal. We wanted to keep it generic so that we can manage any device, no matter which manufacturer. And since it is generic, we allow the app to be extensible to different use cases and domains. So you can start with smart home, like we have shown here with the coffee machine, but there's nothing stopping us to go for more industrial cases, like we see in Siemens with industrial automation or building automation. And once this is here, the value add that we bring is we are able to manage these devices and securely connect to them. We can control the devices by calling their device actions, like we said with brewing a coffee, for example. And we can automate, so we can listen to the events and react to them to accomplish other goals. And yeah, going forward, we can, of course, build more overview of the device, provide dashboards, and anything that you would need for managing this device in your scenario. Yeah, and with this, I can give it to Andy, who will show us how this is really built from ground up.
Okay, thanks for the introduction, Ege. So let's have a look at the architecture. So let's start on the right side with the OpenID provider. So if you're a user of Watt Manager, you just log in with your OpenID credentials. So we support any kind of Keycloak or Azure AD or anything like that. The system itself is built on the platform, which is a horizontal scale-out platform using these dash-join containers. And the actual app, which is the Web of Things manager, is actually developed on GitHub. We'll have a look at the repository later. And from there, it's cloned into the config database. So it contains a bunch of extract, transform, loads processes. There's certain security considerations, there's certain access to the database, queries, access to the APIs and so on. So that makes up the, as well as a couple of layouts. So that makes up the actual application, which is stored in the config database. Northbound, you have obviously an open API interface. So you see the Swagger screenshot here. So you can have third-party components interact with all of the devices via the Watt Manager, as well as the GUI, which we'll see in a little bit. Southbound, first of all, we have the different APIs that we use to connect to the Web of Things devices. We also have a mapping here that plays an important role to homogenize different data feeds and provide a semantically uniform way of representing the device sensor data. On the lower left side, we have the Postgres database that we use to store the thing descriptions. And we also have a large language model, which allows us to interact with the APIs in a more sophisticated way that we'll see in the latter or in the later part of this talk. Okay, let's get started. So the first process that we do is that we connect to the different things and thing registries to discover all of the devices. So that's in the lower right part. And we materialize those thing descriptions in the Postgres database. The thing descriptions are fairly static, so it's okay to cache them basically in the Postgres database. To do that, you also already might require some credentials. So let's say if a Web of Thing repository requires access credentials to obtain the list of devices, you can use that device credential key basically to access the device and the registry. We then save the data in the Postgres database, where we apply row-level security. So depending on your OpenID claims that are associated with your roles, you get to see some, but maybe not all of the devices that we have in the database. So this is how we basically ensure that you only get to see and control the devices that you have access to. So when setting up the system, you basically assign the roles and the credentials to certain user claims and user roles. As we then tap into the devices, read the sensors, and control the actions or call actions, if you have the correct credentials, we basically impersonate the call. So you come in with your OpenID, you have your role mapped, and then the correct set of device credentials, if you're allowed to do that, is used to access the actual device. So how do we interact with the different properties and actions of a device? So here, JSON schema plays a very, very important role. So on the left side of the screen, you can see the water, milk, and chocolate readings of the coffee machine. So that's a sensor that tells us how, what the resource level within the coffee machine is. And that's fairly straightforward. I mean, we talk to the device, we get some JSON back, and then we can visualize that in a generic fashion. At the bottom, you actually see the real code that we use to implement that in the system. So that's a language. The language that we use here is JSONada with a couple of, so that's a JSON query and transformation language. So in the first part, we basically look up the device credentials that are required to, in this case, do a basic authentication against the device. And then we have a curl to do a web access. So we get so value.href, that's basically the endpoint that we talk to. And then if the credentials are set, we apply them. Otherwise, we just provide, we have an open call. The curl command retrieves the water, milk, chocolate structure, which is then visualized on the screen generically. On the right side, you see the actual actions of the coffee machine. And here you need to provide, so you can make a drink and you can set a schedule. So the coffee machine will brew coffee at 7 in the morning every day. And for that, we need a certain payload or a certain instruction set to pass along with the request. Now that instruction set is basically described by a JSON schema. And we also use this very JSON schema, which is part of the thing description, in order to draw a form. So again, here it's important that this form is completely generic, completely dynamic. So the thing or the JSON schema form of the set schedule call, for instance, has a size, which is an enum of small, medium, and large. And it also has the description, which is shown in the tooltip here. So if this thing description changes, the form changes. The only thing that we write as from a what manager perspective is to say, for the current device or the thing that we're visualizing, for each action, take the action's JSON schema and draw a form to drive the action. Okay, the next step, we go from actually controlling individual things more to a dashboarding type scenario. And there, it's very important to be able to access background knowledge. So background knowledge allows us, for instance, we have data sheets of devices where we have the operating temperature. We might have further specifications. Let's say the coffee machine, how many liters of water does the coffee machine take, etc. Something like that. So that's maybe information that it's not provided via the Web of Things API directly, but we can get it from a data sheet which is associated with the device type. Along the same lines, you might have an asset database, which is visualized by a floor plan here. So you can see, let's say, where the coffee machine is located or where a certain sensor is located. And then you can ask things like, what's the, on the certain floor, what's the energy consumption, or things like that. So, or let's say if you're on the shop floor, you can tap into, let's say, an SAP system and find out, the current production set, which customer is that for, what's the actual purchase order associated with the current action on the shop floor. So what we do is we basically take this information into our Postgres database and we just do joins to do more complex queries. And these are some of the queries here. So we have the energy consumption per floor. So in our system, we have energy sensors. In the asset database, we have the information which floor they're on. And we can now aggregate the energy readings and group them by floor. Now, this is actually not all that straightforward because we do have a semantic data harmonization issue because some of the sensors not all of the sensors might be from the same vendor. You might have some from vendor 1, some from vendor 2, which basically return the data or the readings in a slightly different format. You can see that on the top left corner here. And so what we do here is we have a small mapping program that's part of the mapping piece in the architecture to homogenize this information in order to be able to have a dashboard over all of the energy sensors, no matter which vendor they come from. Next up is now we're getting into AI and leveraging AI to interact with devices in a more generic way. So on the left side, we have our brewing interface, and we have a speech input here with a microphone, so we can provide a sentence, 1 huge coffee, please. And on the right side, that's the target payload that we need to feed into the API, which is a JSON payload with drink ID, size, and quantity. And so the challenge is, given the JSON schema description, how can we get from the sentence 1 huge coffee to the JSON? And good news is that the large language models, today's large language models can very easily do this task and extract or basically convert a sentence into such a structure. And they have a JSON schema mode. So all we have to do is take the sentence, 1 huge coffee, say, please convert this to a JSON schema, provide the JSON schema we get from the thing description, and we have a voice command with very, very little effort. So finally, the last, let's say the last piece in the puzzle is to have a more sophisticated use case. Let's have a look at the example. So let's say we're in the building management system and it's the evening and we want to save energy and turn off all lights in unused office spaces. So what you can traditionally do is write a small piece of software that, some Node.js code, for instance, that queries the right API to find out about, used office spaces, unused office spaces, then check if the light is still on, and if it's still on, actually call the action to turn off the light to save energy. And that's a piece of code that you would write by hand and put into a system like the Watt Manager. But now, using large language models, we can actually offload some of this application logic to a large language model, which becomes an agent, and tell the agent to perform this task for us by giving it the tools and exposing the Web of Things actions via large language model tools to the agent, such that this program basically is generated on the fly, and the agent actually comes up with the right sequence of APIs to call and the right feeding the right output of call 1 into the input of call 2. And this works quite well. So we use, in our system, we use Llama index and the respective, making some open API calls available as agent tools. And then you can formulate such a goal, and the algorithm is basically performed on the fly by the large language model, which is quite exciting. So now let's jump into a short demo. One thing that I want to note is that the system is available, so the code is available and the system is live at these URLs. So feel free to check out the paper, the code, and also play with the system. And I'll just do a short run-through demo here. So I can log in using our OpenID provider. Okay, so here we have our coffee machine, and I can make a drink. So let's make a small latte. And if I run this action, you can see that these coffee beans jump down from 71 to 70. Again, I can go into the code here. So this is the actual, I'm now the low-code developer. And you can see that this is just a very small piece of code to actually perform the action. So low-code allows us to develop the system very, very fast. Here's our voice command. So let's try this out. 1 small coffee, please. And we can brew this. And here's the we just dumped the payload that was extracted from the sentence that we just entered. And here's the energy consumption per floor. Again, this is just a simple SQL query with a certain aggregation using the background knowledge and the JSON LD type, which groups all of the sensors in this JSON LD ontology. So very short run through. Again, here is the link to the GitHub repository that contains a short paper on this, and you can also look at the code. All right, so this concludes our presentation. Just a quick summary. Standardization is very, very important. So we have thousands of different types of devices in Web of Things and or in the IoT space, and Web of Things really allows us to interact with them in a concise, homogeneous way. JSON schema is very key to allow us or to reduce the cost in building software that can talk to these devices in a generic way. JSON LD allows us to link with ontologies and categorizing devices. And again, what manager is completely generic, so any type of device that you hook up that we haven't seen while developing the application can be managed generically. And low code is very cool because it allows us to move very fast and also very easily extend the system by providing custom dashboards, new SQL queries, and new ways of visualizing the data. All right, thank you very much.